RS-485 is a standard for serial data transmission of binary data over a network. It is widely used in industrial environments due to its robustness and ability to operate over long distances. For the embedded system engineer, it usually starts with a microcontroller. Most microcontrollers have one or more UART peripherals used for serial data transmission and reception. We can utilize this peripheral for RS-485 communication. 3 pins of the microcontroller are involved in RS-485 communication. TX pin of the UART peripheral, which transmits serial binary data from the microcontroller, RX pin, which receives serial binary data, and a digital output for signaling the direction of the communication. A microcontroller cannot directly output RS-485 data signals. Therefore, we need to use an RS-485 transceiver. We connect the RE pin, receiver enable, and DE pin, driver enable, together to our digital output pin. By setting this output pin high, we tell the transceiver to transmit. By setting it low, we tell it to receive. Some transceivers automatically handle the direction of communication and do not require an output pin for this purpose. Additionally, you can add external circuitry to automate the direction selection. Next, we connect our RX pin to the RO pin of the transceiver and our TX pin to the DI pin, and we have completed all the connections with the MCU and the transceiver. Then we need to power the RS-485 transceiver. It is important to check the datasheet of the transceiver to see the requirements for the power supply. Most RS-485 transceivers work with a supply of 5 volts DC or 3.3 volts DC. Some can accept both. Connect the VCC pin to the positive DC power rail and GND pin to the ground. The A and B pins are used for differential signaling, which means that the signal is transmitted as the difference between 2 voltages. This method helps to improve noise immunity and allows for reliable communication over long distances. When data is transmitted, the voltage difference between pins A and B determines the logical state. A logical 1, also called high, is registered when the voltage on pin A is greater than the voltage on pin B. A logical 0, also called low, is registered when the voltage on pin B is greater than the voltage on pin A. Typically a 200 mV difference is required. You might have noticed, the wires connected to A and B are wrapped around each other. This is called a twisted pair cable. Twisted pair cables are commonly used for differential signaling, such as in RS-485 communication, due to several key advantages that enhance signal integrity and reduce interference. We will explain how they help protect signal integrity in another video. Let's move on with RS-485 network topology. RS-485 can support multiple devices on the same bus, which is called multi-drop configuration. A typical RS-485 bus allows up to 32 devices. More devices can be added to the bus by using RS-485 repeaters, or by using low-load transceivers. Low-load transceivers have reduced unit loads, which means they present a reduced impedance to the bus. This way, the signal can travel along more devices without losing its strength. The RS-485 standard supports up to 32 devices on a bus segment, with each device representing 1 UL, typically 12 kiloohms. Please note how the number of devices increases as the unit load reduces. Proper termination resistors, typically 120 ohms, are required at both ends of the bus to prevent signal reflections. Connect a 120 ohm resistor between the A and B lines at each end of the bus. This wraps up our tutorial. See you in the next video. Please like and subscribe if you have learned something.